back. So here's kind of the generic, what you're going to see in the book, and I'll try to make some sense of that. Here are the symbols, like a U is going to be OR, an AND is going to be an upside down U, and a given is just going to be a slash. So what given means is that we're going to change the denominator. So here's the conditions. I call these the conditions of total possibilities. So I've got a condition A, I've got a condition B, I can have a condition A or B, a condition A and B, and a condition A given B. So that's kind of the generic rule. Now when we look at probabilities, I was using sevens, I was using heads and tails. Now I'm going to be using something a little different. Let's go ahead and say that I have some blocks, like building blocks that children play with. And they're different colors and they are assigned numbers. So I have 10 blocks up here and I'm going to give them conditions. So the conditions that I'm going to give them, let me erase this so I can give you examples. I'm going to give conditions of black. So I have black. What is the probability of black blocks? So I've got 1, 2, 3, 4, 5, and I've got 10 total. So it's going to be 5 over 10 or 50%. So what is the condition for purple? So I have purple blocks. Now I can say how many total outcomes are there? Well, there's 10. So the probability of purple is going to equal 2, so I only have 2 purple ones over 10, which is 20%. Now I have orange over there, and I have total of 10, and I have 3 blocks, so the probability of orange is going to equal 30%. Now I have some other things up here. I have odd numbers, 1, 3, 5, 7, 9, and I have even numbers. So I have 2, 4, 6, 8, 10. So what is the probability of reaching in a bag of 10 blocks and pulling out an even number? Well, what is the probability of even is going to equal, how many even are there? Well, I got 1, 2, 3, 4, and 5. And I got 10 blocks, so it's 5 out of 10, which is 50%. What about odd blocks? What is the probability of pulling out an odd block in a bag? So I have 1, 2, 3, 4, 5. Same thing. I got 5 out of 10 or 50%. Now I can say what is the probability of, let's take this one here. What is the probability of black given even? Now anytime you see the given symbol, it just means to cut the denominator. So right away, given even, we're just saying now I'm going to cut the rest of the possibilities out and I'm only going to be dealing with evens. So I only have 5 evens, so my denominator is going to change. So what is the probability of black given even? So now I got to look at all the blacks given that they're even. So I have even of 1, 2, and that's it. Black given even. So 2 over 5, that is, I have to get my calculator out because I can't think right now. 2 divided by 5, 40, I lost 40%. So 40%. So that's how we would do this. Now, what is the probability of black or orange? So if I have all these blocks, I have 10 blocks, my denominator is 10. So I have all those blocks together and I reach into the bag, and what is the probability of pulling out a black or an orange one? So it's all the black ones, which are 1, 2, 3, 4, and 5, and all the orange, or the orange one, I shouldn't say and, or all the orange ones. So I got 1, 2, 3. Well, there's 8, right? 5, 6, 7, 8. So there's 8 over 10, which would be an 80% probability that you would pull out a black or an orange block. Now we're going to look at what is the probability for pulling out a black and an even. So I'll demonstrate this with what's called a Venn diagram. So I have black and I have even. I'll just use the black pen. So now I have something that's going to have what's called an intersection or an overlap. So I have black and I have even. Now I'm going to say, what is the probability of black and even? So that just means that the possibility has to be black and even. So how many evens do I have? We said 10 right over here. I have 10 or 5 evens. 5 out of 10 were even, so I have 5 evens. So what are they? Well, they're even. I got 10, I've got 8, I've got 6, I've got 4, and I've got 2. So if I'm looking at the blacks, I've got black 1, but it's not even. I got black 2, it is even, so it goes in here. And now I've got 3 is black, it goes over here. I got 4, it's black and even, so it goes in here. I've got 5, it's black, but it's not even. And then I've got 6, it's even, but it's not black, so it goes over here. Now I've got 7, it's not black, and it's not even. And I've got 8, which is even, but it's not black, so it goes in the even. I've got 9, well, it's not black and it's not even, so it goes out here. And then I've got 10, it goes into the even. So what I would do is I would say, what is the probability of something that's black and even? Well, it's right here. And is this intersection. It's in this shaded area here. So I have how many? 4 and 2, which is 2 over a total possibility of 10, because we don't change our denominator, because we didn't say given, so it's 2 over 10, which is equal to 20%. So what is the probability of going into a bag and pulling out a block that's black and even, which would be 2 over 10, which would be 20%. Now that's kind of like the general addition rule, and we're going to say that if I count all of these blacks and I count all of the evens, so if I count all the blacks, I got 1, 2, 3, 4, 5, 5 over 10, that is 50%, right? And I count all the evens, that's 5 out of 10. So that's 50%. So I can't add those together, that would equal 100%. So what I have to do is I have to subtract what's left in the middle, that 2%. So if I add these up, it would be 80%. And so I'm left with that 2% in the middle. So my actual probability of actually pulling a block that's black and even, both together, is only 20%. So that's what we have to do. We just can't add things together. We have to take into account that, oh, if I just add this and add this, I've counted this twice. So if I add the blacks and I add the evens, I've counted what's in the middle twice. So I actually have to subtract that. So when you look at the actual general addition rule, you'll see that you will actually subtract the A and B condition. So the probability of A and B will actually be subtracted from the general addition rule. And then you can say that the probability of A and B is equal to the probability of A, like A or B. So those are some of the little tricks you can use. Don't get too caught up with making this harder than it needs to be. And like I say, the only time that you're going to change your denominator is when you see the symbol for given. So if you have something, some condition given, based on another condition, that will change. Whatever the given condition is, will change your denominator. So since I only have 5 evens, then given that they're even, so if I change this to purple, well, that's going to change my denominator. What is the chance that I would pull out a black given that it's purple? Well, that would be a 0% probability. That cannot happen because I can't go in and pull out a block that's black given that it's purple, because there's only 2 purples and they're not black. So that probability would be 0. I can give you another probability. What is the probability of a black block and an orange block? Well, that probability is going to be 0 as well, because I can't have those conditions. And that's what's called a disjoint. I don't have that possibility. There's no way I can go in and pull out a black and an orange block. I can't do that. I could pull out a black or an orange block, but I can't pull out a black and orange block. So that would be 0 as well. I hope this helps. So this should help you on the homework and some of the questions I may ask. So this is just a very brief probability lesson.